Okay, here's a video on your upcoming assessment. It'll be called Assessment A when you see it Monday. So on your packet it says the Assessment Review Homework on Linear Equations. So here's a question 1 from the packet. You should have your packet. So here we want to make a linear equation. Actually, this is a linear equation we're trying to make with the following points. So here we have these two pairs on a grid, 0, 3, and 6, 9. And we should know by now that the first number is x, second number is y. First number is x, second number is y. So here we are, two pairs, 2 points on a Cartesian grid, or the coordinate plane, whatever you want to call it. So we have our formula for this, which you should know by now. We have the change of y over the change of x. So that's delta y, delta x. That means the change of y over the change of x. And we know that means rise over run. And we have our formula. We have y2 minus y1 over x2 minus x1. And we get the slope of m. Now we've done this in class and there's other videos on it. But basically what we're doing is we're taking the 2 points, 0, 3, 6, 9, and we're using this. So this looks fancy, but we just need 2 y's, and we have 2 y's, and we need 2 x's. So let's use the 2 y's and the 2 x's. So we can do, here's 1 y, we can do 3 minus 9, or we could do 9 minus 3, whatever's easier. So if we did 9 minus 3, we have to divide that over the x's, 6 minus 0. Okay, now we did 9 for y minus the other y, 9 minus 3. This y minus this y. Now since we use this 9, we have to use this 6 for x. Don't mix the pairs. If we use this y first, then we would have to use that x first. So we did this y minus this y, 9 minus 3, and this x minus that x, 6 minus 0. So that's what this comes in. And we know the m means the slope. That's what we're trying to get. We're trying to get the slope. So 9 minus 3 is 6, and 6 minus 0 is 6. So that's 1. The slope is 1. So what do we do with that? Well, we know that the way we do a linear equation in slope-intercept form is y equals mx plus b. And you should know what each letter is. So the m is the slope, which we already know is 1. The b is the y-intercept. And the y-intercept is where the line crosses the y-axis. So if we made a Cartesian grid here, we have the x-axis and the y-axis. The y-intercept is where the line crosses. So if the line crosses here, for example, let's say that was 1, then the y-intercept will be 1. Okay, let's erase that. Now on this grid, make that better, the x is the independent variable. It's all the values of x on the x-axis, left to right. And the y is the outcome. It's the dependent variable. So the x is the input, and the y is the output. So we have y equals mx plus b. That's our slope-intercept form. And we know from when we did the slope was 1. M was 1. So now we know that y equals 1x plus b. Now we don't have to put a 1 next to the x. If you want it there, keep it there. But you don't need it because 1 times any number is that same number. So 1 times x is just x. So we could just write it like this. But if you want to put that 1 there, well, go ahead. Now, remember our points. We had 0, 3, and 6, 9. So what we have to do now is plug in those points on the line here. So any points you want, any pairs you want, we can use 0, 3, or we can use 6, 9. whatever's easier for you. I'll use 0, 3. That means x is 0. Right? And if x is 0, y has to be 3. Now, I could have used 6 and 9. It doesn't matter. I would have gotten the same answer. Now, I'm trying to find b now. So, what you have now, you can see what b is already, because remember, when we're doing algebra, we want to minus the 0 on both sides, cancel it out. But actually, you didn't really have to do that because you know what the answer would be, but we'll just go through with it. So 3 equals b. Remember, whatever you do to one side, you do to the other. So now we know what the slope was, and we know what b is. So we can rewrite the equation now, bring this up. Y equals x plus 3. So that means we can plug in any x, and we'll get a y. So let's say x was 5. If x is 5, y has to be 8. What if x was 6? If x is 6, y has to be 9. Just like we had over here. And if x is 0, y has to be 3, which we had over here. So you should review that by rewinding the tape if you didn't understand it. And also, we have other videos on that if you're still not sure. Let's go to question 2. Here's question 2. Question 2, let's fix that. We want to solve the function. And here's our function up here. So we're just plugging in whatever x is to get y. Remember, x is the independent variable. It's the input. It's the in box. And y is the out box. So just plug in -1 in the equation. So now we'll have -3 times -1. -3 times -1 is 3. Remember, a negative times a negative is a positive. Any like signs when you're multiplying are positive. So we have -3 times -1, so that's 3. And 3 minus 12 is -9. See if you can fill the rest yourself. Okay, so again, just plug in whatever x is. So now we're saying -3 times -2 minus 12, and that'll give us a -6. Same with the others. And we'll get -3, and then you can see there's a pattern going on. Now, you would be wrong to say it's going down each time. It's actually going up. And it's going up because -6 is bigger than -9. And -3 is bigger than -6. And 0 is bigger than -3. Remember, negative numbers are smaller than positive numbers. So we see a pattern that it's going up 3 times each time. Okay, let's do the next question. So here we want to know if this is a function. So we're looking at the red line, not the y. Remember, that's the y and that's the x. We want to now do for a vertical line test. If this passes the vertical line test, well, then it's a function. So what we do is we just take a pen or a pencil, whatever, marker, and make a vertical line. Now, of course, it should be straight, but it doesn't matter. We're just doing a rough sketch here. So it crossed the red line once here, and it crossed once there. If it crosses more than once, it fails. This is not a function. Just to do it again, see, we're making these vertical lines everywhere on the grid, and as you can see, it passes twice each time. You only have to do this once, though. If it passes more than once, it's not a function. So this is not a function. So just to go over that, if we had our grid, this is the y and this was the x, bring that down, and had something like this, So we're just looking at the S now. So let's try the vertical line test. Just draw a vertical line, a straight line down. Does it go past the S more than once? 1, 2, 3 times. It fails. That is not a function. Let's try one more. Here's our X, here's our Y on the grid. Is this a function? Well, let's draw a straight line. Right? It only crossed the line once. So this is a function. Now, a common mistake is some students look at the x-axis. No, don't look at the x-axis. We're only concerned about the line. You drew a straight line and it crossed the line, the linear line here once. So it is a function. Okay, here's question 4 on the packet. And here we want to find the x-intercept. So to get the x-intercept, all we have to do is make y 0. So make y 0. Okay, and we already know the y-intercept. It's right here. Remember when we had this equation, y equals mx plus b, we know the y-intercept is the b, -9. The slope is 4. We know this equation right away is positive because it has a positive slope. It's going up. From left to right, it's going up. So if we did a rough graph of this, it's starting, well not starting, but it crosses the y at -9. If that was -9, that's where it's crossing the y. It's going up 4 and over 1 each time. That's what the slope says. So let's find what the x-intercept is. Remember, make y 0. That's all you have to do, make y 0. Now do some algebra. Let's add the 9 on both sides. Remember, we're doing the opposite operation. We had a -9, so we do a +9. So now 9 equals 4x. Here we have multiplication, because 4 times x is multiplication. So we do division. And here we have it. X equals 9/4. So x equals 9 over 4. Or we can say, if we want to simplify it, x equals 2 1/4. 2 1/4. Or 2.25. So if we look at this now on a grid, let's make a grid here. We have the x and we have the y. So we know that x, here's 1, here's 2, here's 3. So let's say about right here is 2 1/4. There's our x. That's where the line's going to cross the x there. And we know that when y is 0, that's where x is. And we know also that looking at, remember this is the x and that's the y. We know that at -9, that's where it'll cross the y-axis. So we have a rough sketch here of what this line looks like. Okay, let's look at question 5 here. What is the equation of this line? Okay, and there should be arrows on this line, so we'll just put arrows. Okay, very important to put arrows on a line on a test, unless of course you know that the line ends. So we know if we write our equation in slope-intercept form, do it over here, y equals mx plus b. There's a few things we know already just by looking at this line. Well, first of all, we know it's negative because it's going down from left to right. And we know what b is, the y-intercept. It's crossing at 5. So we know that already. So we have y equals mx plus 5. And it's plus 5 because it's on the 5. It's not -5. So we know that already. Now we can get the slope by just looking at a point, any of the points. Here's one point, and see what it takes to get to the next point. Well, it looks like we're going down 2 over 1. Down 2 over 1. That's what we're doing each time. So the slope is -2. We just did the equation. There it is. Now we can check by plugging in numbers. What if x was 0? What should y be? Y should be 5. So when x is 0, y is 5. It checks out. Plug in some other numbers. If x is 1, -2 times 1 is -2. Negative 2 plus 5 is 3. So when x is 1, y should be 3. Checks out. And you could plug in any x that you see here on this line, and you'll get the y to check out. Now, if you didn't do it that way, and you can rewind the tape and do it, see how I did it, you can also find the equation of a line just by finding 2 points. So let's look at 2 points. Let's find 2 pairs on this line. Now again, this is the harder way of doing it. The easier way would be by just what I did before, previously. So I know there is a 0, 5, that's 1. And there's many points on this line, pairs. And there's a 1, 3. But there's many others. Pick the ones you want. Okay, and then if you have 2 points, 2 pairs on the line, you can do the change of y over the change of x, which we did before. That's not an a, that's a delta. But you know you're doing the rise over the run. And you're doing that formula. And the formula here is you're looking for 2 y's and 2 x's to get the slope. Okay, so remember, previously in the video we did this. So we have 2 x's here. We have a 0, we have a 1, we have 2 y's, a 5, and a 3. So we have to subtract whatever ones you want to use. So if I do, let's say, 5 minus 3, that's 1 y, 5 minus 3. Now if I use 5, I have to use 0 for the x. So we'll do 0 minus 1. Okay, so we have 2 on top and negative 1 on the bottom. So the slope is negative 2. So we'll just write it up here, y equals negative 2x plus b. As you can see already, we have our negative 2. Now plug in any x and y's you want. So if x is 0, because we have a 0 for x, we're going to have 0 plus b, right? Y has to be 5. So you can see, well, b has to be 5, just like we did previously. So there's 2 ways of doing this. You can get 2 points, 2 pairs, get the slope, plug it in like we did in the last few seconds ago, actually, a few minutes ago. Or you can do what I did previously. So you have your option here. And it's easier basically to see that where it's the y-intercept's 5, and to get any other point, you have to go down 2 over 1. Down 2 over 1. Now, if you went up 2 over 1, you're still going to the left. You're not going to the right. And you would still have a negative slope. Okay, here's question 6. Change from standard form to slope-intercept form. So this is in standard form. There's an x and y on one side of the equation. We want slope-intercept form. Remember, slope-intercept form has y alone, like this. So we want to get the y alone, and the y is not alone. We have this 6x in its way. So we're going to minus this entire 6x, and then we're going to bring it on this side. So now we're left, make a line, with negative 2y equals negative 6x minus 12. Now we went over this in class. You could say minus 12 minus 6x, or you can say minus 6x minus 12. If you're not comfortable with that, you can just say, we'll just do it again, negative 2y equals negative 12 minus 6x. Okay? So if you want to do it this way or you want to do it this way, it doesn't matter. So now the y is still not alone. We have to get that negative 2 out of there by dividing. Remember, you're doing the opposite operations. That cancels. And then we want to divide the negative 2 to both of these. Alright, bring that up. So we have our y by itself now. Negative 2 divided by negative 12 divided by negative 2 will give us a 6, because negative and negative, like terms, will become positive. And the same here, we have like terms. So a negative 6x divided by negative 2 will give us a negative 3x. So there's our equation. Now, usually it's written with the x first, so we'll have the y equals negative 3x plus 6. There's the equation. Now, you could have kept it this way also. It's the same thing. Let me just write this again here. We had y equals 6 minus 3x. It's not minus 3x. It's actually plus. So let's go to the original. Bring this down for a minute. Why is it plus? Because remember we had negative 2y equals a negative 12 minus 6x. Let's just erase this for a minute. So we divide the negative 2 out on both sides. So we're going to have y alone. Negative and negative is positive, so it's going to be 6. Negative and negative is positive, so it's going to be a positive number plus 3x. So not minus 3x. So it should be y equals this, or you can write it like this. You can write it like this. It's mostly written this way in textbooks and what you'll see in high school, but not always. Sometimes you'll see it like this. So again, it should be plus, and the reason why it's plus is negative and negative is positive. Very important. Here's question 7. In question 7, we want to know if the line here, this line, linear equation here, we want to know if it's continuous or discrete. So remember, if it's continuous, it has a solid line. Solid line, straight through. So this is continuous. If it was discrete, it would have dotted lines. With a continuous function, we know that the x values, remember x is there, there's our y, every value on the x is included on this line. But with a discrete function, it's not. So let me draw a discrete function. If we had, draw a graph here, there's our x, there's our y, bring that over. So with a discrete function, you have, it's not a solid line, you have dotted lines like that. And it could be in any direction. So with discrete, not every value of the x is included in the line. Like if we did in class, we did people. Right? You can have 1 person, 2 people, 3 people, 4 people, but you can't have 1.5 of a person, and so forth. That's why people, let's say people and points, whatever the case may be, what is happening here, we don't know, but we know that you can't have 1.5 or 2.5 or 1.3 and so forth. So that'll be discrete because it's not a solid line. Now if you have, let me just go back to this question we had. Here you have a solid line, but it looks like you have these points. Well, they're just giving us little helpers of where each pair is, but there's many other pairs. You can put a pair here, 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 here. If you see that line crossing, though, it's solid. So try to understand the difference between discrete, which this was, and continuous solid line. Question 8, we wanted you to sketch an equation, and it said y equals fx plus 0. Now if you see plus 0, you don't even care about the 0. You can just get rid of it right away. So we know that the slope is 5. And since you had 0, the y-intercept is 0. So let's bring it down actually. We'll make a little graph. We're just sketching it, that's all. It doesn't have to be perfect. We know it doesn't start at 0, but we know it crosses at 0. So from 0, the slope is saying go up 5. 1, 2, 3, 4, 5. Go up 5 over 1. And we're doing that all the time. Up 5 over 1. Or we can go down 5 and over 1 the other way. So there is our rough sketch. And we don't know the content behind it. We don't know if it's continuous or discrete. And since we don't know, we just put a solid line. And by the way, if it goes through the origin, and we know it goes through the origin because it said plus 0, which you don't need, then it's proportional. This is a proportional linear equation. And just to make sure you understand this, if you see this solid line here, we know this is continuous because it's a solid line. But if I put that x is people, then this can't be, because as you can see, yes, you can have 2 people and 4 people, but you can have 5 people, but you can't have 2.5 or 3.5 or 4.5. So this, if you see the solid line, this would have to be discrete. You would say this should be on a test, you would say it can't be a solid line because you can't divide people up in half. Okay, so the last question we have for the assessment, number 9, does the following have one solution, no solution, or many? Okay, so the first thing we want to do is we want to combine like terms. So we have a 12x and an x. So 12x and x, we can get 13x. So we have 13x minus 3. We can combine on the other side, 5x and 8x. We can combine them. Right? And that, again, that'll be 13x minus 4. Now, you could probably see right now there's a problem. But let's continue. So if we want to get rid of, we want one of these x's alone. So let's say I add the 3 on both sides. So we have a 13x now alone equals 13x minus 1. Okay. Then if I get rid of a 13x on both sides, I get a final answer of 0 equals negative 1. This contradicts. If you remember in class, if something contradicts, there's no solution. So this would have no solution. So again, if you ever see something, let's erase this. If you ever see where you do your answer and x equals something, like let's say x equals 5 or 6, whatever, then there's one solution. If x equals something, one solution. But if you get at the end where you have like a 0 equals 3 or a 5 equals 6, it contradicts. There's no solution. No solution. One solution, no solution. Now if you get it where you get the same number, let's say 0 equals 0, or 3 equals 3, or 7 equals 7, or it doesn't matter what it is, it could be half equals half. If you have one thing equaling the same thing, then you have many solutions. Many solutions. So just to make sure you understand, let me give you one more equation. Let's fix this now. What if I had, let's do 5x plus 8, bring that over, and minus 7x, let's say, and we'll have it equal negative 4x, and let's say plus 1. Yeah, plus 1, okay. So let's try that. What do we get? Well, let's combine like terms on this side. 5x minus 7x will give us a minus 2x plus 8 equals a negative 4x plus 1. Okay, so if I get rid of the 1 by minusing it on both sides, bring that over. Now I have a negative 2x plus 7 equals negative 4x. Now I can get rid of the x by adding, because it's a minus 2x, so I can plus the 2x on both sides. Bring that over. And now we have that 7 is going to equal negative 2x. Divide out the negative 2 on both sides, and we now have x equaling something. And if x equals something, in this case negative 7 over 2, there's one solution. Okay, so again, if it has one solution, then there's one solution, right? That means that x is going to equal something, in this case negative 7 over 2. If there is no solution, it contradicts, like we talked about previously with this question. 0 equals negative 1. Shouldn't be. Or there could be many solutions when the same number equals the same number. Okay, so that's the assessment. Those are the 9 questions. I would review that, rewind the tape if you need to. Good luck.